everybody, my name is Eduards. I came from Latvia. Actually, I came from London since I have relocated to London about 2 weeks ago to start working as a software development manager in a pretty a big organization. But the thing is that I don't really like London, so I'm considering moving back to Latvia because it's much more cozy and all this stuff. Today I'm going to talk about continuous delivery, and everything that I'm going to talk about is actually based on real-world experience. So, real-world companies, real-world experience, real lessons learned. Some things might not make sense for you if you work in a small organization, let's say a team of 5, something, because at this scale you don't have much problem with continuous delivery, so you just can easily come up with agreement. However, eventually you will grow, all right? So you might face the same issues as the companies I'm going to mention will actually had a chance to face. So let's start, and it's mostly about people. It's not about technology, right? So we're not going to talk about Docker stuff like a Kubernetes, like in that room, right? So, fine. Let's start with the first issue that normally happens with a large organizations. It's called like a lack of organizational alignment. Have you heard about the term shadow IT? Shadow IT? So shadow IT is something that happens when part of the organization does something without approval from the rest of the organization. So like when company, let's say, tries to implement continuous delivery in a dark room, in a separate room without the rest of the organization, right? That's how we usually do that, right? And here's the story that happened in a fintech startup in Germany about a year ago. So once the team decided to implement continuous delivery, they wanted to move fast. And they gathered a meeting and start to brainstorm, how should we start? So they decided that a great idea is to start deploying once a day. Like bring the pain forward. Let's start deploying like a functionality once a day, and that's the first step. Kind of logical, right? Kind of logical. That's a good stuff. So, and they used to have sprints, and they used to have to deploy software once in 2 weeks. So, but before doing continuous delivery, they went to ops guys, which in this particular organization was a separate team. Separate ops guys, and they were so excited, they came to the ops guys and asked, hey ops guys, since today, we're going to deploy software once a day. Ops guys are staring at them, and what did they say? What the answer was? They said, fuck off. They said, fuck off, never, it's just impossible, because, are you crazy? Once a day? They said, fuck off. And you know what was the reaction from a developer side? Fuck off, as well, fuck off, and they left, developers left. And the reason behind this denial was actually that according to current process, ops guys had to go through a list of changes that goes to production once in 2 weeks before a sprint. Not the best change management process, but that was something that they agreed on, which is like so far so good. So developers left, and in the dark room, they decided to go their own way. They started deploying once in a day. Bam, bam, bam. Things go fine, and in order to make sure that they don't get blamed from ops guys, they decide that, we will prepare a list of changes once in 2 weeks and send them to ops guys. That's a trick, right? So you deploy once a day, but anyway, in order to to not get enough attention from ops guys, you prepare a list of changes and send them to ops guys. Kind of like everything is the same, right? Nice. So far so good. Everything went smoothly, and eventually production went down. Production went down. Ops guy received a call from a manager. What's wrong? We're down. We're not making money. And it took them about 6 hours to recover from this downtime because they have a failure on the integration side. And the thing is that the major reason behind this 6-hour downtime was the fact that developers didn't really want to admit that they deploy once a day. Because they were afraid of blame. They were just afraid of blame. That was a pretty dangerous situation, but they didn't want the truth to bubble up. And consequences were very dramatic. So first of all, SLA was missed. And this particular integration partner was their competitive advantage, basically. It was very hard for this company to come to agreement with the integration partner and start making money. So they lost about like a 20K customer, and the thing is that every transaction was very expensive. Like a high-cost transaction. It was a Forex business. Do you understand what does it mean for a startup to miss 20K customers? Can you understand what does it mean? It's a disaster, right? It's just a disaster. It's just a disaster. So they lost trust between management and IT, obviously. They lost trust between dev and ops, and team lead was fired. Next day, and that's what the companies usually do with the smart guys who think that they're smarter than the rest of the organization, right? So, because it's much more harder to wake up and just come to agreement with ops guys, let's say. And the thing is that about a few weeks ago, I received a call from my friend who is still working with this company, and they went bankrupt. They went bankrupt, actually, because there was a butterfly effect. Small, tiny miscommunication led company to bankruptcy, and that's it. They were not able to find one more integration partner with whom they can make money. Boom. Butterfly effect. So what can we learn from that? The first of all, is continuous delivery is a human system. It's not about like a software stuff. And in every human system, alignment is vital. So you have to make sure that everyone is on the same frequency. Everyone comes to agreement. Everyone, with no exception. It's hard. We're not best communicators, right? That's not the reason why we chose this job, right? So, but anyway, alignment is vital. You can't really pull complex system in different directions. That's how it works. That's a priority number one. And I wanted to say, before I heard the previous speech, I wanted to say that you have to make sure that everyone rides the same bus. But now I'm afraid. Have you heard of this bus factor? Right, so we can hit. So I wanted to say that everyone should ride the same bus, and now I heard that everyone shouldn't actually ride the same bus. So it's a controversial one. So we should see a reason behind every denial. Basically, if someone says no, there should be a reason for that. You like it or not, there's a reason. There's a reason. You can't just go away. There is a reason. And it's about empathy, actually. So why, if we tried, let's say, to work as an ops guy for a few weeks, I think that a lot of questions will just disappear naturally because it's a completely different job. It's a completely different job. We have to start empathizing, right? Or doing pair ops. We're doing pair programming, right? We're doing pair QA. But we're not doing pair ops. We don't usually get this feedback from ops guys. And we have to learn to compromise, because the thing is that before 2 weeks deployments and single day deployment, there are 50 shades of gray. There are 50 shades of gray. You can do it once in a week. Fine with that. Don't go to the extreme from the first shot, right? Okay. And I like this one. Usually, you can't come to agreement with someone because someone just argues in the sake of arguing. Just someone doesn't like you or doesn't like your idea or has bad experience. I like this. Apply beer-driven diplomacy. So basically, if someone does not agree with you, don't argue. Take this guy, go to a bar, have a beer, and listen. Just listen. Don't answer, just listen. Next day, you'll come to work, and somehow, magically, most of the complaints disappear, right? It just works. It's a magic silver bullet in the change management. That's how we change stuff. Just go for a beer, listen. Next day, problem solved. Usually works for me. I use it often. That's why I have belly. One more thing. I think that it's still not a common practice. We don't really move ops to cross-functional teams. Usually there's a still group of like a DevOps guys, as we call them, right? But they're still separate. Where you don't have a separate QA departments anymore. I hope so. I hope so. I hope so. Oh, it sounds like a you probably have, right? But yeah, you shouldn't really have this QA departments, right? But like a common industry practice is just making sure that QA people are part of the team. So why ops guys are still not part of our teams? Why we don't have full-time DevOps guy in the team? DevOps guy. Why? Because we could actually learn from them and make sure that we work together. Communication will be much more better. Problem solved. So. And the major complaint is actually that's because ops guys are usually responsible for infrastructure, security, something. How we make sure as a company that ops guys are on the same wavelengths? How do we make sure that we build infrastructure in a consistent way, have unified security rules? And it's a problem already solved at Spotify, actually, because Spotify has something that's called chapters, right? Like communities of expertise. It's solved already. It's solved. You hire smart people. They will figure out how to communicate. Don't think that people are stupid. They can't talk to each other. They just can't talk. Okay, do it on a regular basis. Run something like a DevOps, I don't know, lessons learned once in a week. That's it. Problem solved. Just they should talk. Okay, nice. Relying on a Tiger team. That's how companies tend to implement continuous delivery. And here's the story. FinTech enterprise Latvia, 1.5 years ago. Management decided that companies should go faster. So why not to go in the continuous delivery direction? Every team member was overutilized. Everyone like a sprinting, working on the features, bug fix, and firefighting all the time. So what they decided to do? Instead of giving teams time, they decided to create a separate team called like a Tiger team, a team that will solve all companies' problems, right? Eventually, they will introduce continuous delivery, and the rest of the company will pick up, right? That's a brilliant idea. Wow. In a dark room, Tigers implemented something that's called deployment pipeline. Using all fancy technologies, Docker, I don't know, Kubernetes, what else is there? Everything, like a Jenkins, whatever. So they played with plenty of new technologies and had fun. However, well, it's a separate team and they don't really deploy software, right? So in order to get acceptance from the sprinting teams, they went to sprinting teams and say, hey folks, what if you deploy next time using our deployment pipeline they have built? And what sprinting teams said? They said, fuck off. You know why? Because we don't have time for playing your games. Because we're firefighting and you guys are playing games. We don't care really. We know how to deploy. That's a pretty angry answer, but that was true. They don't care. That's not their problem. Pipeline was not their problem. And it introduced natural conflict between the natural tension. Tigers left. They came back with the management and set a gentle deadline. What if you guys deploy via pipeline in 2 weeks? Since overtimes were paid, slaves said yes. Okay. So there are tigers and slaves. Slaves said, okay, fine with it. So somewhere at night, they tried to make deployment via pipeline, and after like several bug fixes introduced by Tiger team because it didn't really work well, they managed to make pipeline green. Engineered. Tigers are happy. Tigers are happy. Slaves don't give a shit. But they're happy too, because tigers are happy, and slaves can continue sprinting, right? But what's funny is actually the next deployment by sprinting slave team was made in an old fashion. And why? Because they're used to it, it's more convenient, and just in spite of tigers. Just in spite of tigers, because you build that. You build that. So what can we learn from this? I believe that overutilized slaves actually can't do continuous delivery, and tigers will not help them. It just doesn't work. You have to make sure that adoptions come from the inside out. So basically, instead of building a tiger team, give your regular teams some time and give them enough coaching on continuous delivery. Give them support. Make sure that they have time. Just give them support. Don't build new teams, because these slaves will eventually feel better. They should feel like a tigers. Hey, we will now do continuous delivery. We are a delivery team. We will benefit from it. That's what you should build. You have to make sure that sprinting teams are tigers. Don't build new teams. Never do that. It just doesn't work. And because overutilized teams can't do continuous delivery anyway. You will have to find time for these guys to apply these practices, because continuous delivery is a journey. It's not a marathon. It's just journey. You can't do it from the first shot once. You can't do it from the first shot. Instead of doing continuous delivery with the tiger team, make sure that the team has time, and you build culture of continuous improvement, because actually continuous improvement is something that leads to continuous delivery eventually, but not vice versa. The thing is that if team does not have continuous improvement culture, you will never get continuous delivery, because it's a journey. That's the reason why consultants can bring continuous delivery to your company. They join your company, they write tests, they build pipelines, and what happens next? They leave. Software evolves, company evolves. How do you solve problems next without them? You have to make sure that you learn how to solve your problems. Just give time, give some freedom. Okay? Newton laws, the enemies, and I like this one, because in the software development, in the world, in a life in general, there are rules that we have to obey. We have to just follow them. You can't really change them. And one of them, you have actually heard about it already, it's like Conways Law. So the Conways Law, the simplified version, says that basically your communication structure, your communication flow between teams will have direct impact on your architecture. And it's a law, it's not a good idea. It's a law. You can't change it. So the way how teams talk to each other will have direct impact on architecture. Direct one. And that's what I saw once. There was a team in Latvia, the country where I'm from, working on a single code base, and they were happy enough. They've been doing continuous delivery, actually deploying software very often, doing programming solely on the main line, doing pair programming. They didn't even have a branching at all, all the fancy stuff. But then management decided to bring a new more team, and they hired them in the United States, which actually means that wall bubbled up between these two teams because there was no time overlap. The team was actually in California, so there was no time overlap at all. So wall bubble up, no time overlap, and there's the cultural differences. We're just different. We're just different people. And that's the reality. However, they didn't really know what to do. And management too, they thought that that's okay, right? That's how it is, right? Just bring the pain forward. Just bring the pain forward. You'll figure out how to solve problems. And naturally, teams will come up with the effective way how to talk, how to change architecture, blah, blah. Bring the pain forward. Woohoo! And the systems start to crack. Somewhere in between, it just starts to crack. Because of Conway's Law. Because in order to avoid communication penalty, and it was painful to communicate, they started to avoid communication at all. They started to isolate from each other. They work on the same code base, but they are isolating from each other. They work as a two independent team. They don't do pairing. They work solely in the feature branches. They don't integrate enough. They don't talk enough. They don't run inter-team stand-ups. Boom. So, and that's an interesting one. Code grows, architecture grows, and it grows siloed, because basically knowledge islands bubble up on different sides. So basically when team in Latvia looks at the code, it can find something that they don't really know about at all. well, in a crappy fashion, written in a crappy fashion, probably. And let's say if I work in a team in Latvia, chances are that changes introduced by the American team can lead to a rollback, which leads to some blaming, right? Because there are cultural differences as well, and they're just guys in the United States, and we have separate goals. So continuous delivery ended up continuous blaming. So right, they just blamed each other all the day because they have different goals and the shared code base. So the thing is that there's one more interpretation of a Conways Law, basically says your team structure will override any architecture you have. Any architecture you have. So what could they do? It's like a checkmate. That's it. They just blow the whole idea of continuous delivery. So what could they do? They had this situation: shared code base, multiple teams working on a shared code base, and there's a wall between them. This is worst possible scenario, right? They could, in theory, do something like a UI, middleware, DB stuff. It was a complex application. However, the thing is that, can you really deliver value by doing changes solely on a middleware or on a DB? You can't. So we have to reason, like in this slice, how to deliver value effectively, not a code. We're not like a coding monkeys, right? How to deliver value. So what if we try to organize teams around business capabilities? That's what like a Conways Law and microservice architecture tries to push us towards. So basically, what if we try to give teams autonomy and ownership over their code? So to eliminate this clash, two separate teams owning their stuff, having their own product owners, even having their own money. It's about making sure that there is autonomy. Autonomy leads to faster delivery. So, and the thing is that this is a very interesting point, I believe, because continuous delivery may require your organization to change, because it's very often when your organization grows, you change team structure, right? You change something, you hire new people to develop software, blah, blah. However, your architecture evolves as well, but why don't we strike back? Why don't we change organization as well? Your architecture evolves, it should impact your organization as well, but we don't do it as an industry. We change solely technical side most of the time, right? That's how it is. We're not comfortable with going back and changing organization. We don't do that. And what's important is actually, since you can't really do your architecture right from the first shot, you can't do it right from the first shot. So yeah, there will be a talk about evolutionary architecture tomorrow. Since you can't really do architecture right from the first shot, organizational agility is very important. It should evolve together with your architecture, but we don't do that. Okay. So bring the pain forward, right? Bring the pain forward. However, some teams have very high pain tolerance. They just suffer and then just boil. They just boil. They don't know what to do. They just boil until they die eventually. They just boil. Bring the pain forward. But pain usually leads to painkillers. So they don't go, the usual teams don't go to doctor. They just eat painkillers and make things worse. So usually they have problems and they don't have enough help from the outside, maybe. And respect Newton's laws of software development, because they are there. If they knew something like a Conways Law, they would probably ended up cleaning the basement and changing architecture before bringing the team, or at least cleaning up the mess before going fast. And there are many more laws that we have to follow. Let's say this one. It's hard to object, right? How does a project get to be a year late? 1 day at a time. Can you object? You can. That's a law, right? So the thing is that there are much more, and I encourage you to go through these friends. Basically, it's a classic, right? It's full of cool ideas. It's just classic. You have to go and read this one. If you want to learn how to organize your software development, basically, how to organize teams around architecture, how to organize architecture around teams, go for this one. It's a great one as well. Number 4, misunderstanding of fundamental principles. And I like that, because here's a small list of something that I saw in the real world. Teams tend to work solely on the main line, right? That's what continuous delivery teach us to do, right? Because we have to continuously integrate. But I saw teams suffering a lot because they keep it as granted. Maybe you work on something that you will never need to integrate back to your main line. Some prototype idea, like throwaway stuff, but they suffer with like a feature branching on the code level, trying to make sure that it integrates, but that's a throwaway stuff. That's a throwaway, so it's not for everything, right? We like building deployment pipelines. However, the goal is not to build deployment pipeline, it's to make sure that your deployment is consistent and reliable. So actually, I saw totally inconsistent deployment pipeline. So I test something and I deploy something totally different. So, however, I saw reliable and consistent releases without a pipeline. So you don't really need a pipeline to make it right, but people are like, "Hey, pipeline, blah, blah, cool, like all these rectangles with the steps," but it's not reliable. Or this one. We have to test our software on production-like environment. Really? Why? Because to mitigate risk. I saw teams buying very expensive hardware to make sure that they test on the same environment. However, it's about risk. Maybe you can afford some risk of failure. Maybe you can do that. Maybe you can reduce time to recover, time to detect. Maybe you don't have really to spend time. It's a balance. It's about money at the end of the day. What's more effective, to buy hardware or to accept the risk? And that's my favorite. If something's difficult or painful, do it more often. If it hurts, do it more frequently. And here's an example. I have a brick. I have a head. And I hit my head against the brick. It hurts, right? It's painful. Should I do it frequently? Just a totally wrong idea, right? So we usually apply this and it's dangerous. So what if you're just doing the wrong thing? You're doing just wrong thing. Or what if I'm just doing things wrong? What if I should only change direction in order to achieve the goal? That's a difference. Okay? One more thing. My personal statistics shows that usually teams who tend to go towards continuous delivery, they don't really understand the fundamental principles. They kind of understand practices, they read blogs, some articles, but it's a really fragmented knowledge. You should understand the principles and whys behind every principle at the end of the day. So really, encourage you to go and read the classics. This is something that actually has a lot of ideas and will structurize your information, because usually we make obvious mistakes just because we don't understand the ideas and principles. Just read some philosophy behind continuous delivery as well, not only like how to do pipelines or, I don't know. Or you can actually invite me for a coffee as well, because you can benefit from the fact that I'm unemployed, so because I work as a consultant, so you can benefit from the fact that I'm unemployed. We tend to optimize the wrong thing. Because let's say we want to move fast, right? We want to move fast. We want to move faster than a day before all the time. However, what is the scope of this moving fast? Do you want to move fast as a person? Do you want to move fast as a team? Do you want to move fast as an organization? Because these three levels, they are usually in a conflict. Because let's say, here's the example. You have a development team, developers in your team, and a QA testers, QA professionals. So if you produce a lot of development work, you suboptimize the whole because you overutilize QA, right? And you know what overutilized people tend to do, right? They do crap. Either they burn up or they do crap. So this is a simple example of when we try to optimize something locally, but they optimize the whole thing. And usually if you visualize how it looks like in your, Kanban board, it looks like this. Right? That's how it is. Like a bunch of things in testing. So it's a bottleneck. And what if we try to apply work in progress limit? What if we set artificial constraints? What if you say that we can't really have more than one item in testing? Wow, one item in testing. How can it work? And why do we need that? So how it's going to look like if we set this constraint? It's going to look like that, like this. right? And why? Because it has very interesting psychological effect on the team. So in order to move forward, you have to finish existing things first. This is psychology. It's not about technology. It's a simple rule. If I want to push things forward, I need to finish the existing work first. However, the next step is limiting work in progress and development. And we end up with something like this, because it doesn't make sense to develop something that is like that's either will never be completed or just stays, right? Why? Why we have to push out this batching out of our value stream? Why? Because there's a Little's law. Have you heard about Little's law? Little's law? Little's law. Okay, because of Little's law, basically, what Little's law says that there's a linear relationship between number of things that are in progress and average lead time. So average lead times actually says that how fast we can move on average with the features. Let's say, here's a question. So we have 32 cards in process, total work in progress limit, and a throughput of 2 cards a day. So what is the average cycle time? How many features we can produce in average per? What is the cycle time? How many days? 16 days, exactly, 16 days. So if card number grows, average lead time increases, or cycle time, lead time, whatever, it increases. So if I want to make sure that it takes, let's say, 1 day to deliver functionality on average, that's important. What should I do? I have to either reduce the work in progress batch size or increase throughput. So that's it. And it's not very obvious, I think so. For some reason, we're still batching. We try to batch stuff because there are bottlenecks, but that's how it works. So it doesn't make sense, actually. It doesn't matter how many items in progress you have, like this, because they are still not done, right? There's no value for them. They're still not done. It doesn't make sense whether they are in testing. They're still not done. There's no value. There's no value at all. Okay? So the thing is that we have to optimize the whole, and because in every system there's only one constraint that limits your capacity. It doesn't matter how much work in development you can produce. If there's a bottleneck on the testing side, there's a bottleneck, and it just stops the value stream. You can't move faster than the bottleneck. That's it, right? So it doesn't really make sense. If you want to have a single takeaway from this presentation, then it will be this one. One completed feature or something that's completed beats like 100 items in progress. It doesn't matter how much items you have in the progress. Complete at least something, get feedback, right? And this is for QA. Do we have QA professionals in this room? Nice, I love that. So the thing is, my friends, if you want to make sure that this never happens, make sure that your priority is not testing, but testing facilitation. Push the testing back to development team. Push it back to development team. Like, become a testing facilitator, not a tester. Be a facilitator, right? So testing is everyone's responsibility. Developer, tester, what's the difference? Just merge these 2 columns together, make sure that they are work in progress. It doesn't really matter where it is, in testing or in development. It's work in progress, and make sure that everyone is doing that. So be testing facilitators. It will solve a lot of problems. I once applied a very interesting trick in my life. So basically, I had a team which never had a time for making sure that acceptance test maintained by QA person runs on Jenkins. They never had a time. So what I did, I said, QA, what if you go to vacation for 2 weeks? QA girl went to vacation, and just after a few days, I saw tests running on Jenkins, because you can't really deploy without this, right? It's natural. So my idea was to continue this, like maybe make sure that QA never comes back to work. But be careful, we still need QA, but we have to make sure that we push back, right? If you want to learn about this and more, I encourage you to read this one. It's like make things clear. Delivering wrong thing. Continuous delivery saying about moving faster, da 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 da. But we forget about value. We should deliver valuable things. It's not about delivering something faster, it's about delivering valuable things. Because if you so the biggest waste is actually automating something that shouldn't be automated, right? So, and usually continuous delivery looks like something like this. That's how pieces of shit, valueless, and they reliably, without failures. I would prefer them to fail somewhere in the middle and just fall down, but they reliably travel towards production and smash the wall like a and smash the production, hit the end user, and so before doing continuous delivery or before doing these things reliably, it's like you never do these things reliably, right? So never do these things at all, because before doing continuous delivery, we have to understand actually what value really means. What is value? For whom? For your customers, for your stakeholders, for your partners, for your service consumers, whoever. You should understand what value is before doing it reliably, right? So we have to end up better in value mining. So as like you have to do like a Bitcoin mining stuff. So you have to mine value, like constantly look for ways how to make your increase the value, like how to mine it, how to find it. So that's what I call value mining. How to mine value? Genshin Genbutsu, obviously, go and see yourself. Go and see what your customer is doing. I'm not going to talk about it. However, it makes a lot of sense when you just go and look, because it's obvious. So work closely with customer service team, experiment. Have you heard about prototyping? Prototyping, not proto, but prototyping. So prototyping is actually, the difference between prototyping is actually that in case of prototyping, you don't have to build anything. You have to pretend that you build something, right? And just become a customer. So the thing is that there's an idea of vanity metrics. It doesn't make sense how many features you produce. You have to produce value. Basically, it doesn't really matter how much output do you have. Concentrate on outcomes or on impacts that you made, right? Like a work smart, not hard, right? Technical obsession. Famous product company, Australia. Technical stack, AWS and Capistrano. Boring, right? AWS, everyone is using AWS. Capistrano, it's boring as well. So, they want to introduce continuous deployment. And team decide, it sure would be fun to use Docker, right? Because everyone is using it. Everyone. Or they say that they use it. And it opens new opportunities. So they took CoreOS, installed it. The best operating system for managing containers, right? Very famous. They took Mrs., installed on top of it, because you want to program to your data center the same way as you program to your laptop, right? Of course, it's a good idea. They took Marathon, installed on top of Mrs., probably because you have to run long-living processes. That's how it did. And a month later, Hydra was born. And what is Hydra? So Hydra is a monster which possesses many heads. So, and I like it. More heads than painters could paint. Basically, the thing is that it brings much more problem than you can imagine, than you can expect. And for each head you cut off, grew two more. So you solve problem and more bubble up. That's what they built. And they actually became slaves of something that they have built. After 3 months long war, they were fighting with Hydra, we'll still stick to this stack, fighting. They suffered many losses and capitulated. It's like they decided it's a dead end. It's just dead end. No way to go. So they decided to roll back and spend a month on it. And drama is that it took them only 2 weeks to solve the initial problem. 2 weeks with AWS and Capistrano to implement continuous deployment. That's a disaster, because given costs that are nowadays, how much money you spend on IT, it's a disaster. And here's a takeaway. I like this one. This is a golden rule of everything. So give me fancy technologies that is used nowadays, at least one. What's modern nowadays? Docker. Docker is like teenage sex. Everyone is talking about it, but few have actually done it. Well, works. Something else? Spark. Spark is like teenage sex. Everyone is talking about it, but few have actually done it. You see, it's like a theory of everything, right? That's how it is. And even if everyone is doing it, because you doesn't mean that you have to, because let's say in case of the teenage sex, I don't know what's in Ukraine, but in case of teenage sex, it's a criminal offense. So don't do that, right? Because everyone is doing that. Law of leak abstraction. So the more abstractions you have, the more painful it becomes at the end of the day, because they start to leak and you have to understand everything all the way down. There's even a term called complexity tax. So complexity tax is the price you pay for features that you don't use, but they slow you down. That's why I don't like Jira, let's say. Okay, fine. The last one, giving up too early. There are complaints. People are complaining all the time when you push pressure. I don't keep up with testing. There are so many things to test. I don't keep up. We have to slow down. Let's roll back. Let's start sprinting. Working in the trunk is a stupid idea because of course at the beginning things start to fail, right? No junk in trunk. Let's say you can't really change the things because let's say QA guys have a different manager and he has a separate opinion. I heard that. Deployment is so cumbersome, we can't do it very often. Or I like this one. You really want me to talk to security guy? Serious? With this grumpy guy? No way. Or this one, it doesn't work for us. Our company is so special, it's so different. Like a Tesla, we're building rockets, right? No one do the same. That's how we feel. And I'm proud of you. That's nice, good that you have this feeling, but it's probably not true. So, that's a common misconception. Continuous delivery causes so many problems. Right? So many problems. Wow, it's insane how we can work this way. However, the truth is actually that it reveals so many problems in your process because there's an effect of acceleration in software development. The faster you go, the more things that you have to unlearn. Unlearn. Not unlearn, but unlearn. You have to unlearn new habits, and that's what's painful, right? So there are obstacles all the time. People cry, people die, people leave companies. But the problem is that the major obstacles, let's say if you work in a huge organization, right? You probably, who works in a huge organization, like a big one? Not many. Okay, lucky you. So the thing is that, in fact, everything can change. Like even small company, a big one can change. It depends how much effort should you put, obviously, how much effort and how to approach the problem, but it can change. And you need motivation, right? The change starts with motivation all the time. So, if you want to motivate yourself to start doing things better, you can learn actually how huge organizations can do continuous delivery at scale. Huge organizations, how they transform their organization towards continuous delivery. If you want to change the world, your company, go for this one. In fact, you don't really need to change the world because you have to start changing only your small company, which at the world scale is pretty small regardless how big it is really. So, just keep running, like in this movie, Run, Forrest, Run, and never give up because you have to remember that actually inspiration comes just after you start doing something. You can't really wait for inspiration. Once you start doing, once you start pushing the boundaries, you become inspired. So otherwise, inspiration might never come to you. Thank you.